Very good morning, friends. I hope all of you can hear me loud and clear. Please, can I get yes in the chat window? You can type whatever, however your yes. Yes. Thank you very much. Sanju, Prasad, Kevin, Saju Rajan, Santosh, Vivek, Rakesh, Ashok. Yes, friends. Yang, Iqbal, Bijoy, Rajesh Kumar, Anita, Pulkit, Mayank. Nice to see all of you here. So this is Tejas here from Bangalore. So I will be your instructor for this Hadoop developer course, right? To just tell about myself, to just brief about myself, I do have almost around 18 plus years of IT experience. In 1997 itself, I got Sun certified. After that, almost 10 years I worked on Java based projects, desktop applications, web applications. From last 3+ years, we can say we started working on Hadoop, right? So initially when we started, almost a year, right, we used just Hadoop as a data source. We didn't do much on analytics on data Hadoop. So that means you need to understand Hadoop is best suitable for data source, right? Like nowadays, you might all know now. So Hadoop is becoming like a de facto standard to store data, right? Because of its, I can say just now, I can say it is as a feature. So today and tomorrow, we'll try to understand why Hadoop is best, right? So almost we started working on sensor data analytics. When we started, we moved all our sensor data to this Hadoop cluster. We started with almost around 20 servers, right? So when I say servers, it's normal, usual commodity computers, right? With almost around 5 terabytes of data each, right? Around 2 to 10 terabytes varied, right? So, almost from 1 year again, we started looking at store keeping unit forecasting, where all this retail industry supply chain management data we keep, and then we do forecasting. Again, we use Hadoop for it. Again, we need to deal with main huge data, so we just move it on to Hadoop again, because when we process again in store keeping unit forecasting, we process years together data, 2 years to 3 years. So we say 24 months data. So we find moving averages based on that, and then best fit, all those things analysis we do on. Basically for SKU forecasting, we do analysis, right? So I will be your instructor for this developer course, and this, how it works is, this class what we are attending now is a live online class, right? So almost 3 hours, and then weekly 2 sessions we will have. So 5 weeks in total. That means sorry. So 6 hours per week into 5 weeks, 30 hours in total, right? So today, tomorrow, I will tell you what are the modules we will be covering. So whatever we do today, right? So class recordings, that means this video will be uploaded to your learning management system, right? LMS. I hope all of you would have got this login credential for this LMS, right? I hope all of you would have got the mails. Probably if anyone would have not still got this login credential for learning management system, after this session itself, please do write to Hadoop support team, right? So let me type this email, support@edureka.in, right? edureka.co. So yeah, so as I said, this live classes recording will be available to you maybe maximum say around 4 to 6 hours maximum. So because I need to download again, upload to Edureka website, and then Edureka again has to map it to your LMS, right? So maximum we say around 4 to 6 hours. So we will be uploading our video recordings, and we also have 24/7 support. So anytime, please, you can feel free to request, write to us or call us. So now if you are facing any kind of challenge, probably installing software or running some programs or understanding some terminologies, so anything to do with running program itself, you're getting stuck, or getting software when you are some of the virtual machines what we provide, you have some issues, any issues, I mean to say, probably you can just write to us 24/7 support. So ticket will be raised, right? So and then we will follow based on your tickets. We will reply, I mean we will answer all of your queries, right? So in this LMS we also have module wise quizzes and assignments. Module wise quizzes and assignments. So each module when you finish, you can try attend this quiz assignments for you to get more knowledge, right? And at the end of the session you may have to work on one project and deliver to us. So we will be giving you data sets, problem statements. So maybe we will give choices, so you may have to choose any one which best fit for you, and then you deliver that as a project. Probably after this session, I'm talking of complete after this 5 weeks, right? You can start working on this POC project. Maybe again take around 3 to 4 weeks of time, and then within that you may have to deliver. So once when you deliver this, right, we'll give you, you will all get certificates, right? So that is verifiable certificate. Anytime any company wants to verify that certificate, they can log into Edureka and then see about your certificates. They can verify. So this is about brief about our course. So before I go ahead, please can I get a small introduction of all of you friends? Maybe just a number of years and which domain you work on. That will be really helpful, right? Yes, good evening Yogi. Yes, Prasad, Mithun Raja, Shivanand. Yes. So working as database beginner 6 years, database designer. Okay, Saju. Fantastic. So Salesforce systems 8 years, Rakesh. 7+ experience, insurance domain, Bijoyce. Fantastic. Praveen 9 years, nice. So 4+ Young, 4+ QA engineer, 18 years IT experience. FoxPro COBOL, almost Shivanand. I started programming in FoxPro. Though I learned COBOL, I didn't get a chance to work on COBOL, but yes, FoxPro then is nice to see Shivanand, 18+ years experience. So Santosh 10+ analytics report, fantastic. Saju again 7+ years. Sharmila mainframes, insurance domain, fantastic friends. Vivek 3 years. Imanshu 4+. Pulkit 7+. Finance domain, Radesh 10+ years experience, fantastic. So Oracle Unix banking and finance, Praveen again 18 years. Prasad architect, nice to see, nice friends. Mithun Raja 3 years experience. Santosh VBA QA. Kevin again 3+ years experience, is it? Fantastic. 15 years internet consumer product development, fantastic. Anant, probably some of the use cases we may require your help because you are already into internet consumer product, probably 15 years. Let us discuss this as we go ahead, right? So yes, Shivanand. ETL HANA, fantastic Yogi. So Anish again 12+. Gagan management consultant, fantastic. So yes, Anish, Pearl, Yogesh, retail, healthcare, yes friends. So nice to see many of you, I mean more than at least minimum of 5 to 6 years of IT experience. So now I assume all of you might have gone through a lot of videos and understood probably some of the concepts, at least basic concepts about Hadoop. So before I go ahead, let me take you through all these modules, right, what we train in this session. So first module, that is today, we will be covering understanding big data and Hadoop itself. So we will see many times you might have heard about big data. We will see what is meaning of this big data, right? And then how Hadoop can easily digest this big data and then process. So what are the main components of Hadoop itself? We'll try to understand today, right? And then tomorrow we will see architecture and then how to do cluster configurations. So complete Hadoop architecture and cluster configurations, and then also our own virtual machine we have, and then we have installed Apache Hadoop on that. I will take you through that again entire VM and how to access your Hadoop. So today, tomorrow, more kind of a architecture and understanding how to use the platform, right? So basic understanding of components and then architecture and then platform, how to use it, we'll try to see today and tomorrow. And then next week, right, module 3 and 4, we'll be seeing MapReduce framework. So when I say MapReduce, it is basically processing framework, right? So we'll be writing programs to analyze the data. So how to analyze data using MapReduce, we will see next week, and also we'll see advanced MapReduce. So module 6 and 7, we will be seeing tools like Pig and Hive. Again, though Pig and Hive tools internally uses MapReduce framework to execute, as a user, right, we will be giving high-level commands here to analyze the data. Meaning, when I say MapReduce, we will be writing code in Java program, because Hadoop itself is written in Java, and then it is optimized to execute Java-based MapReduce programs more. So Hadoop is optimized to run Java-based MapReduce programs. Basically, so we will be learning how to write Java programs as MapReduce and then execute, we will see here. So when I say Pig and Hive, this is basically for non-Java developers, right? So if you are non-Java developer, you don't have to worry. So you need to focus more on this modules, module 6 and 7, right? So again, when I say 6, it is high level commands you will use, and it's very simple language called Pig Latin. And we have Hive, which is almost equivalent to your SQL based queries. So I mean to say in Hive, right? So you will be using SQL based queries to analyze the data. Again, we will see in deep of advanced Hive, and we will also touch base on HBase. Basically, we call it as NoSQL database, which sits on top of Hadoop, right? So now HBase is a NoSQL database. We will see how to use it, what is NoSQL database means, and why do we require another database on top of Hadoop, right? So all these things we will see in detail, right? And module 10 is where we'll focus mainly on to your project, right? So what you need to do, how you need to progress, which stack of this, basically whether MapReduce, Pig, Hive, HBase, what to use in your project, why to use. So also along with this, we will also see some of the data loading techniques along with Oozie, right? So Oozie is basically a workflow engine or scheduler, we can call it as. Along with this, we will also see Scoop, Flume, right? So data loading techniques, when I say that, so non-Hadoop environment data, how to pull to Hadoop. Mean to say, probably we'll see how to get RDBMS data to Hadoop. When I say Hadoop, I am talking to file system itself. I am talking to Hive tables again. As I said, Hive uses SQL based queries. So in Hive, we also create tables and manage the data, right? So we will also, that is like some of the data loading techniques also we'll see along with this. So when I say this, you don't need to worry. We don't wait till year to see how to load the data. Maybe today, tomorrow itself, we will see how to use a simple command line interface. I mean shell commands, I mean to say. So how to use shell commands to do load data, we will see tomorrow itself, right? So what is Hadoop cluster? When you understand, we'll also see how to load the data, right? So I suggest, right, if you refresh before you go ahead actually onto this Hadoop course, maybe you would have done this as an early, maybe pre-learn course, right? So I suggest all of you to go through Linux-based shell commands and Hadoop, Java, core Java language. I mean, say at least basic core Java programming, how to open Eclipse. So if you learn all these things before we start actually programming, that is next week, and then practicals, when we start actual practicals, I suggest if you all go through basic Linux shell commands, core Java, it will be really helpful. And also maybe say, as I said, module 7, we look at Hive. So if you can refresh all your SQL based queries, right? how to insert data, how to fetch data probably. So we don't do any row level updates, deletes though here. We just analyze the data. So if you can learn that much, that is enough. How to fetch the data and then how to analyze simple SQL based queries. So that is good enough to start working on this, right? So this is about course. So can you recommend any books? Yes, Gagan, basically best when you start, right? You to start with, you can look at Hadoop Definitive Guide. Hadoop Definitive Guide is the right book. So maybe you can also start with Hadoop in Action. It is a simple English. Maybe a couple of chapters when you finish in Hadoop in Action, then you can switch over to uh, Hadoop Definitive Guide by Tom Wright. So it can be any DB, or is it limited to HBase? It can be any DB, or is it limited to HBase? I think you're talking about HBase running on Hadoop, is it? So it is now for time being, you understand this is the NoSQL database, which is the only database which runs so tightly coupled with the Hadoop, right? So basically, when I say that, the HBase internally stores all the data onto Hadoop again. So now, first thing what you need to understand is Hadoop basically a distributed file system. When I say file system, I hope all of you understand, right? Simple like Windows, Linux file systems. So Hadoop is basically a distributed file system. That means Hadoop runs on top of clusters of machines. Cluster means group of servers or machines, right? So Hadoop can be installed in a cluster, and then it's a distributed file system itself, right? So don't worry, let me take you through entire architecture today. Tomorrow you will definitely get well understood, right? Well understanding of this. So how to join class, we have all understood. Maybe again login through credentials. So if you have not logged through simple mail, right? So you can also log in through your LMS and then join to our sessions, right? Click on my course and join the class. So we will be giving complete VM virtual machine setup to you. You need to download Oracle virtual machine and then you need to install this, right? So we are using I think it is CentOS and 32-bit on this virtual machine. So you can install on any machine, whether it is you have Windows, or in fact if you have Linux box also, I suggest install this VM, because we have included all the source code programs, whatever we show as demo as we go ahead, right? All these are available in this virtual machine, right? So setting up Edureka Hadoop cluster on your system is what we expect. So today, tomorrow, right after this session, you may have to do this exercise. We'll give you fully configured VM which you can practice Hadoop 2.2, right? And cluster workspace, you just need to follow this document here in your LMS. You just need to follow this document, right? So in how to install, and then you can also download split files, and then you can install VM. Do you need VM, or I can install on CentOS servers? So in VM we have CentOS and then all Hadoop installed, right? So I suggest that if you are good at Linux, right, and then you have already installed Linux servers, any flavor, I mean to say Ubuntu or Red Hat, so you want to install on your own, right? We will also welcome that. So, but first for us to be easy, quick learn, so if you can install this VM, that will be really helpful. Yogi. VM supports 32, yes, 32 plus 64, both, Ashok. Something like this, your VM will be something like this. So though I do have here 64-bit Linux, so now this, our VM is 6.5 Red Hat 32-bit, it runs fine. You don't need to worry on a virtual box, right? So Edureka is the password, username and password. You will be seeing your desktop something like this, right? maybe 1 or 2 files I have just added apart from these 2 files, right? So you should see Eclipse, you should see LMS folders and README file. Let me take you through as we go ahead, right? So this will be your Oracle virtual machine, and you will be using this for all your practical purposes. So at the end of this module, right, you will be able to understand what is big data, right, and what are the limitations of existing data architecture, data analytics architecture, and how can we overcome with all these limitations by using Hadoop. We'll try to understand, right, and we'll also see complete Hadoop ecosystem, right, and Hadoop 2 main components architecture, right. Also we'll discuss, when I say you move data to Hadoop, right, so what happens internally, how to read, write in Hadoop, what happens internally. We'll see what is rack awareness. We have something, if you have multiple racks, so if you have installed your Hadoop cluster into multiple racks, what happens when you write data? So that we call it as rack awareness. We will see in detail. Also, let me explore our VM, right? Since I have sent OS, I'm not major fan of Windows. Yes, Yogi. So if you are used to it, that's really nice, right? So again, initially Hadoop is developed to run on Linux. I mean to say Hadoop runs completely on Linux OS, right? So Red Hat servers is extensively used basically in actual production. So let us look at what is big data, right? Today we are all surrounded by data. Basically people upload videos, take pictures on their cell phones, right? Text friends, forums. So you just go to any forums and then you write comments, reviews. Technical forums, you will update technical queries or results, right? So what are we trying to do? It's nothing but we are contributing to big data, right? Nowadays machines, devices also generate data, RFID readers, camera, right? So sensors data, if you see, we get from microphones, refrigerators, washing machines, ACs, right? So nothing but collection. We are talking of big data, right? So big data is a term for large collection of data, whether it is structured, unstructured, or semi-structured. So big data is the term for large collection of data. We already started talking about terabytes, petabytes of data, right? So that too, you can see a lot of work industries, organizations generate terabytes of data even per day, right? Example like social media sites like Facebook, Twitter. So these, they generate terabytes of data per day. You can imagine the volume, right? So now big data is the term for collection of data so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. That means big data is very much challenged to do anything with it. Not only just manage or use through some database management tools. Challenges include just to capture, curation means maintaining it, so storage, search, sharing, transfer, analysis, visualization, anything to do with data. So it is, maybe if you see, it is so big and complex means variety of data, right? Too much varieties of data, complex data, structured, unstructured data, what we are talking. So it is difficult to process or do it. It is challenge to do with anything, to whether say capturing, sharing, you want to analyze, you want to visualize the data itself, just to store also it is problem. So volume and then variety is what we say, right? So huge data which becomes difficult to manage, we call it as big data, right? So now systems and enterprises, as I said, they started generating terabytes of data even per day. So generate huge amount of data from terabytes and even petabytes of information. Stock exchange, if you see, stock market generates about terabytes of new trade data per day. Again, as I said, data when it generated, we just not store and maintain it, right? We also need to analyze or process that data. So to perform stock trading analytics to determine trends for optimal trades. So stock market store these kind of volumes to perform stock trading analytics. So that means we analyze the data, right? So it is not only just storing, we do analytics also. So that's again challenge to do with anything because of volume and variety of data, big data. So if you see, unstructured data is exploding more. If you see this graph, almost if you see, unstructured data is more than 80% of the actual total data, right? So we say structured, unstructured data. Structured data means I am referring to the data which is coming from majority like RDBMS data, right? Why we say structured data refer to RDBMS? Because RDBMS, that is databases itself, stands as gatekeeper and verifies before it writes the data to the tables. So you will define schema before you write the data. So database itself stands as gatekeeper and verifies what data you are writing. Right? So we know size, we know type before we write the data, we store the data. That's where we say structured, all those as structured data. But coming back, unstructured data, when I say that, maybe anything like say any data like audio files, video files, JSON data, XML data, TSV files, CSV files, all this we refer as unstructured data, which is getting generated more and more day by day, right? So by 2020, we predict almost we'll have globally around 40 zettabytes of data. When I say zettabytes, so 1000 terabytes is 1 petabytes, 1000 petabytes is 1 exabytes, and 1000 exabyte is 1 zettabytes. So you can imagine the volume, right? So zettabytes is represented by 1 followed by 21 zeros. You can just imagine the size of data what we are talking, 40 zettabytes, right? So world's information is doubling every 2 years, right? So compared to almost around 2012, so it will be generating, we will be generating more than 50 times of the data, existing data, right, by 2020, 50 times. So IBM also says big data spans in these 4 dimensions. Initially they started talking about 3 dimensions. Now they've also added veracity, which will impose challenge to do anything to handle with or store and process with. So what is this direction? I mean 4 dimensions, that is velocity, volume, variety, veracity, right? So we say volume, that means I already said we started talking about zettabytes of data, right? Now to just process also, so you want to need to analyze any data, you need to analyze, now you need to deal with terabytes of data. For example, so Twitter you might have all know, right? So Twitter tweets, if you need to analyze, so to do product sentiment analysis, Twitter has to go through or manage or analyze almost around more than 10 to 15 terabytes of tweets. So that is volume what we are talking. So you want to predict power consumption, basically you need to go through more than 400 billion annual meter reading records. You can imagine the volume of data you need to manage, right? So to do analysis or processing of data, so you need to deal with huge volumes of data. So velocity, basically speed at which this data is getting generated again imposes challenge to us, right? So daily we get more than 5 million trade events generated online and 500 million CDRs, call detail records. When we talk of telecommunication industries, so we know CDRs, right? Call detail records. So per day, 500 million CDRs gets generated. So velocity, and Twitter itself, if you see, more than 5,000 to 6,000 tweets will get generated per second. So that's where I said speed at which this data is generated is too much, right? So now variety is lots and lots of types of data. When we talk of big data, so we say data we get from multiple sources. So multiple source data will be variety of data, right? So audio files, image files, video files, weblogs, maybe again TSV, CSV, JSON, XML files, right? So sensor data. So variety of data is also challenging, and veracity. Veracity is, we say inconsistency in data. That means data not available itself. Sometimes we refer it as sparse data, lot of data not being filled, right? So uncertainty due to data inconsistency or incompleteness, we call it as veracity. So all this volume, velocity, variety, veracity, right? So that is the biggest challenge. That's where we have a lot of hurdles to process this and then manage anything to do with. That's what, as I said, so anything to do with whether you want to capture, that means you want to collect the data from source, right? Again, it is challenge because of variety, because of volume, right? So Curate maintaining itself for long term, maybe you want to maintain that and then manage it and then you analyze or use it. So again, it is challenge. Storage itself, because of volume, it is challenge, right? Anything to do with. So that is big data, right? So big data is the term for the collection of data sets. It is so large and complex, so it becomes difficult to do with anything of this, right? That is about big data. So now in between we have Annie asking you some of the questions, right? Probably this will be like a quick refresher for whatever you have learned. So now maybe we'll start with a small query. So Annie wants you to map, right? So what type of this data files are? Probably XML file, whether it is unstructured or completely semi-structured or completely unstructured data or structured data, right? So Annie wants, just if you can type, right, 1 this, 2 this, 3 this, 4 this, that is good enough, friends. Just if you can type, so that is good enough. Let me read out. So fantastic, Venkat. Semi unstructured, unstructured, structured, fantastic, Venkat. So yes, Sanju, Saju, Imanshu, Mithun, Pulkit, Bijais. Yes. Yes, Sanju, Anant. Yes, Praveen. Praveen, just first one you need to modify, that's it. So otherwise everything is fine. Yes, Bimal, fantastic. Mithun, Raja, Gagan, nice friends. Probably if you have written in a single line, that would have been helpful, because it is, this window is just scrolling up, right? So fantastic. Yes, Santosh, nice. Yes, Yogi, Mayank. So now, yes, many of you almost there, so fantastic. So that's where I said probably I understand all of you might have gone through a lot of videos, understood basic things about Hadoop, right? As I said, you should have basic knowledge of Java programming. I hope all of you would have done it. So if you are very new and then you need to learn, again in our LMS we also have Java essentials, right? So essentials videos, you can please download all those videos and then practice at your end, right? Yes, coming back, XML, yes, semi-structured data, words, docs, PDFs, text files, structured data, right? Sorry, unstructured data, and email unstructured data, and data from ERP, CRM tools. Yes, we refer it as structured data. As I said, because we use maybe RDBMS as the backend to store data, right? So why do we call this XML, maybe again TSV, CSV files as semi-structured data? Excel, XML, TSV, CSV. Here, though we have pattern of data. For example, when I say CSV files, say now, probably let me just explain about once. Whether it is XML or say for example XML, let us take books, right? So we might have inside books, we might have book tag, right? So now you might have many book tag, maybe again author. Just let me. So you might have author, maybe again, maybe year of publication, whatever. So dot dot dot. Let me give. So maybe again, if you see some of the tags, right? So say for example, notes about the book itself. Notes about book, maybe about book. I will write. So if you try to see this tag, right? Mainly this tag. So others, though we know author, year of publication, maybe price, we can imagine to certain level, probably data type and then size, whatever. So but if you see these kind of tags, right? Notes or reviews, weblogs, sometimes when many weblogs, if you see, we just write reviews, right? So based on reviews, so if assume reviews, say you are getting book review also here, right? These are completely unstructured data. That's where we say semi-structured data. Though we have pattern, we understand, okay, first column is author, maybe again column wise, if here again if you say first name, last name, age, profession, right? Maybe something about some description, or so about, or something related to some, maybe some description again we can say, or city, all these are fixed. Maybe again some describe about personal, I mean if you are taking about data about persons, so you have some notes or description. This may be again completely unstructured data, right? No size, no data types, we can have these kind of tags. So that's why though we have pattern data, so some of the columns may be completely unstructured. That's where we may semi-structured, we may call it as semi-structured data, right? And again, as I said, words, PDFs, text files, email body, we refer it as completely unstructured data. No size, no type, we can define here to easily manipulate it, right? But again, compared to structured data, yes, we have a lot of standards, primary key, foreign key, right? So searching, row level updates, deletes, that's where it is easy here as far as structured data is concerned, right? Yes, now okay, fantastic, Vivek. So so we do have a lot of blogs developed for you. Maybe again, please, I request all of you to, whenever you get time, right? I request all of you to just go through all these things. So now more on big data, why Hadoop, again, opportunities in Hadoop, right? So what is big data, IBM's definitions in details, so you can go through, right? And you can also request if any new technology or terminology you want to create a blog. Yes, you can request, we will definitely welcome that and then develop and give it to you, right? So some of the common big data customers scenario we will see, right? So now if you see lot of industries, verticals, now they have started using, first as I said, we have all started using Hadoop as a data source itself. Later we worry of analysis, right? So now what kind of analysis, what kind of different industries, verticals, right? So and then what kind of analysis they do, let us see. So for example, web and e-tailing industries, they want to come out with recommendation engines, ad targeting, search quality, abuse and click fraud detection. So all this has to do with huge, has to deal with huge data. Recommendation engines, for example. So initially, if you see if you say to tell little about our experience in recommendation engines, right? So almost I'm talking of around little before 2000, that is around 1998 itself. So when I was working for a retail industry, right? So FoxPro, point of sale billing data, said they wanted a recommendation when user buys, right, for some products, they wanted at billing again cross verify, right, before the billing. So they wanted to recommend that time. So what we have done is for specific product, this list of recommendations we prepared in the database itself. So we mapped in the database itself, when that billing particular product comes, it used to refer, so it used to list to the point of sale guy. So the salesperson used to mention them to recommend them to this, maybe some discounts, maybe some, yeah, as I said, discounts, everything. So recommendation we hard coded into the database, I mean to say, because data was not so huge when we talk of FoxPro application, though we used to manage retail data. When I say point of sale data, we used to manage thousands. It was not so big, right? So nowadays, if in any online portal like Amazon has to give recommendation of some products when you buy online, so it has to deal with huge data. Analytics is not on simple data, volume of data, so it has to deal with huge data, right? So recommendation engines, ad targeting again, so customer based ad targeting if you have to do, search quality, and then fraud detection, everything, it has to deal with huge data. In telecommunication industries, again, customer churn prevention, as I said, so CDRs, more than 500 million CDRs is generated per day. So again, to manage this kind of churn prevention in telecommunication industries, it's not easy, right? So network performance optimization, CDR analysis, again, network to predict failure, analyzing network to predict failure itself has to be deal with huge data, right? So now government project itself, we all know now in India, Aadhaar is implemented on Hadoop, right? So again, refer to Aadhaar, so retina scan, thumb scanners, retina, all these are images, right? So you can imagine images of all, so if you can imagine the size, right? Huge volume of data, again, we are using Hadoop itself. Again, fraud detection and cyber security, welfare scheme, justice. So all this data has to be dealt with huge volume of, all these are dealt with huge volume of data, right? Again, healthcare, life sciences, health information exchange, gene sequencing, serialization. So drug safety, anything to do with, it's not simple, right? So healthcare data also, multiple sources of data, they get generated in healthcare, right? So MRI scans, CT scans, so you need to analyze, you need to deal with huge data. Again, banks and finance industries, modeling true risk, threat analysis, again fraud detection, right? Trade surveillance, again credit scoring and analysis, anything to do with, we need to deal with huge data. Nowadays, these banks, financial industries, they even refer real-time market feeds data, social media data, right? So that means when you go, you write something about, say, some insurance product in, say, Facebook, so they will get to know about it, right? They will all be reading those things. So they've all started now analyzing. So real-time market feed, social media data, right, along with existing database. So they all analyze social media data also now. So retail industries, again, point of sale transaction analysis, customer churn analysis, sentiment analysis, right? So now you go to any Reliance in India, you go to any Reliance outlets, they may give you some membership card, right? So whenever you buy or purchase anything, so you may have to tell that card details. Just to basically analyze buying patterns of customers and improve the service, right? So maybe to maintain the stocks also, that will be really helpful, right? Sears is one of the biggest retail chain industry. So what is the hidden treasure? We have seen so much industries, all verticals, they started, I mean, all these analytics we started talking about to deal with huge data, right? So what is the biggest advantage and hidden treasure? That is, insight into data can provide business advantage. For example, healthcare industry, if you take, analyzing disease patterns and trends, they can model future demand and save a lot of and make good strategic R&D investment, right? That is business advantage. Some key early indicators mean fortune to business. Like as I said, financial industries, they analyze through transactions, they analyze real-time market feeds, they go through social media data, existing database to find odd behavior and minimize odd behavior of customers and try to minimize the risk, right? And more precise analysis with more data. Again, retail industry, so now analyzing point of sale data or doing sorry. So by analyzing this point of sale data itself, we can get new insights to deliver highly targeted customers, right? Retailers can do location-based promotions in real time by analyzing these kind of data, years together data, right? One of the simple example, if you see Sears, right, they were using this Teradata, Oracle, SAS for their IT infrastructure. They used to do with this with traditional system. They used to manage with this. Now they have moved to Hadoop. I hope I have this figure. See, yes, Sears has moved to a 300 node Hadoop cluster to keep 100% of its data available. So when I say 300 node, I am referring to 300 servers of a single cluster, one cluster which has 300 nodes, servers. When I say node, please, you can also consider as a server or a system, right? So single cluster, Sears has now 300 nodes to store their data. So when I say for example, each node 10 terabyte of data, right? Each node, if it is 10 terabyte of data, so how much in total they can store and manage data? That is 3000 terabytes, right? 3000 terabytes means 3 petabytes of data they can manage. CS can manage, assuming 10 terabytes average on this, right? So that's how now Sears says they use Hadoop to maintain 100% of data available for processing rather than just 10% as was in the case of non-Hadoop solutions. So that means in the existing infrastructure, they could able to manage maximum say 10 to 20% of data. So now because they are using Hadoop, they are managing 100% of data to do high-end analysis, right? What is churn analysis? Basically, customer churning, say telecommunication industries, maybe customers leaving some service providers and joining, say maybe you are leaving some ABC service provider and taking some other service providers. So leaving the customers, leaving the service providers, that is churning, right? So if you refer telecommunication industries, so it will be really difficult for them to market for new customers, right? So yeah, I mean to say it is not cost effective. So what they do is at least they need to prevent this churning, right? So they will take care of lot of analysis to prevent customer churning. Do you have examples of recommendation engine? recommendation engine. Basically, we in Hadoop, you might have heard by this time now. We have a tool called Mahout, which is a recommendation engine. Maybe when I go ahead on ecosystem, I will explain this, Yogi. Yes. So fraud detection, basically maybe again online transactions, so online sales companies, so they need to work on fraud detection, right? Yes. Retail industries, web portals, right? So now let us discuss limitation of existing data analytics architecture. When I say existing data analytics, I'm not referring to, that is just I'm referring to non-Hadoop infrastructure, right? So if you refer many industries now, all of them they have started using Hadoop, right? So this presentation we are taken from Yahoo's one of the presentation almost by around 2011, right? So now let us understand this to make sure and then to appreciate how Hadoop is different from this existing storage and then analysis, right? Infrastructure. Now this slide, as I said, Yahoo means you can imagine what kind of volume they day to day they collect, right? Terabytes of data. If we see bottom layer, we have instrumentation layer. So instrumentation layer means this is where data is getting generated, right? Web servers, cache registers, network equipments, system logs, application servers, software logs, RFID readers data, maybe machine devices data, wireless sensors, networks data. So collection unit, so we will have pipelines, so to take this data and then move it on to a storage grade. We call it as raw data, original raw data, so only storage grade. So I hope all of you know we used to use really big high-end servers to manage this kind of data storage, right? Now here again we use ETL tools to take data whatever is needed to our applications, right? Maybe BI tools, interactive applications, whatever data is required, we used to use ETL tools to extract, transform and load this data to RDBMS database to be used by applications, right? So now probably when I go, before I go ahead, please can I get some list of ETL tools, friends? Just maybe sample list of ETL tools. You know, Informatica, yes, Saju. SSIS, Talent, yes, friends, fantastic. Yes, Talent, Ab initio, fantastic. Yes, right. So data stage, yes. Pentaho, PDI, Pentaho data integration also we have, right? So now what we do, we use ETL tools to take this data, whatever data required, right, by these applications or reports, and then we do ETL is just extract, transform, data cleans of the cleaning of the data. I'm sorry, friends. So data cleaning, aggregation, joining, all these things we do using UTL, and then move it on to RDBMS for being used by some other applications, right? So if you see limitations, if you try and understand in this flow, right? So we can't explore original high fidelity raw data. That is true, right? Because we are just taking some subset of data, cleaning it and then moving on to RDBMS, which is actually required by these applications. That's where we are not getting chance to analyze the raw data, complete raw data which is getting generated, right? And problem is it doesn't, moving data also doesn't scale, right? So entire this terabytes of data, if it is getting generated daily, can we move it on to RDBMS? No, right? It doesn't scale. So that's where what we do, basically applications data or reports, anything data whichever is required, that much data we extract, load to this RDBMS. So moving data also Sorry, moving data also doesn't scale to this compute layer. And one more limitation, if you see, premature data death, we say. That is, so because as I said, we use higher end solutions in storage grid, it may not be a good solution if you look at cost benefit. So what we do, what normally industries do is maybe around 18 months, 24 months older data, right? Older than 18 months, 24 months, maybe based on the industries, organizations need. So what they do is they will take this data older than 2 years data, they will take it into backups, maybe again tapes. For an example, they may take it onto, they may take it as a backup. So why I call premature data death is when you want to analyze timely, it may not be possible to access the data. That is because you have taken as backup. So there may be a process. You may have to take higher authority permission. You may have to write why you want to read the data, old data. Again, that itself may be a big process. Right? That itself may take weeks of time if you consider big companies like Yahoo. Right? That's where we say premature data death. So these are some of the limitations of existing data analytics architecture. Right? So now let us see what is this Hadoop brings to us to overcome all these kind of limitations. So to understand this, first you need to understand what is Hadoop itself, right? So Hadoop is a combined storage plus compute layer. Means Hadoop is storage plus compute grid. So mainly if you see Hadoop is made up of two components, we call it as SDFS and MapReduce, right? So SDFS takes care of storage and maintaining of the data, and MapReduce take care of analyzing or processing the data. So in Hadoop we have storage plus compute grid together. So when I say this, again I said it is a distributed file system, right? So multiple servers you can use here to store data, huge volume of data. So now when I say we are merging compute and storage grid, right? Here, as in this case, what happened was data we used to do ETL and put it onto RDBMS. And when you run analytics, that is when you run programs, applications, maybe take example of web applications, data used to go from database servers to the application layer, to the processing layer, right? But here in Hadoop, right, we say it is merged together. That means, sorry, in Hadoop, processing will be taken to the data. Rather here reverse, right? In the existing architecture, data will be taken to the processing layer, but here when we say Hadoop, we take process to the data layer. So that's where we say it is merged together. Well, let me again in detail, let me explain what happens when you write data, how to process everything, you will understand very well. So for time being, you understand Hadoop mixes both, that is storage and compute grid. So that means you can analyze complete data, that is data exploration and advanced analytics you can do because you are dealing with complete raw data, not only subset data as in this previous case. So now you are dealing with huge raw data, so you can do advanced analytics. So we have discussed some of the advantages here, right? Insight into data can provide business advantage, fortune to business, more precise analysis with more data, right? So all this is advantage here because we are processing with huge data. Now, yes, again, you need data to be extracted out of this aggregated output again to be moved on to RDBMS for some BI reports or application. Yes, that is also possible now. So on the entire raw data, you run through applications, take results, probably again aggregated result, you want to move it onto RDBMS, you can do that. We have tools, many basically to import and export from Hadoop, like for example Scoop. So with Scoop, probably we can, it is very simple to take the result of the first stage processing to the RDBMS. Maybe you just want to show some graphs or BA reports to be used as aggregated data, you can move that now. That's where is scalable throughput for ETL and aggregation. So here Hadoop, first you need to understand it is optimized to access batches of data quicker. When I say batch, it is optimized to access batches of data. What happens is Hadoop splits data into big chunks, right? And then distributes across clusters and then process in parallel. That's where we say scalable throughput. So we can do ETL here itself, and then whatever result we need, we can move that to here. Result we get, we can move that to RDBMS layer. So in Hadoop, again, we use commodity computers. You don't need, when I say Hadoop, biggest advantage is you don't need higher end servers to store and manage the data and also process the data. Right? You don't need higher end servers. So when I say that, when you are getting increased with the data, you will just add nodes. Because you use simple commodity computers. Say for example, you are managing with 100 terabytes of data today, probably tomorrow again, say another another 50 terabytes of data you need to handle. So today you are managing with 10 systems, 10 terabytes each. You can just add another 5 nodes without changing anything in the existing architecture. You just add servers and then start using it to store huge volume of incoming data. That's where we say we can keep data alive forever in Hadoop. We don't need to worry about storage capacity and then computing layer here, because Hadoop uses commodity computers. You don't need higher end servers. That's where you see numbers like this. When I say Hadoop cluster, so 3 petabytes of data, if you see each 10 terabytes node, so you can easily, maybe again, as I said, we were referring to Sears, right? So Sears can manage 3 petabytes of data here, right? So conclusion is Hadoop is a combined storage compute layer. So data never has to move around because we are dealing with huge volume of data. So combined compute layer means compute can be done at this level itself. You can do, whether you can do ETL, aggregated ETL or anything, so is done at this level itself. That's where we say scalable throughput, advanced analytics, keep data forever, right? So you need to actually understand in detail architecture. Let me take through slowly what is this. When I say storage and compute grid, what happens? So when you move a file in to Hadoop, what happens, you need to understand to appreciate this, right? Let us now slowly go and understand what is this storage and compute layer, right? Maybe again, if we come back, you will understand very well, right? So any queries as far as these 2 slides, please you can type now. I will answer all of your queries, right? But how does data storage issue being solved here? Yes, we will discuss that, Saju. This also would require backup and purge after a period of time, right? You mean to say Scoop, is it? We will discuss this, Saju. Basically, first let us understand slowly this. What do I mean by storage compute layer? So now, once you understand this, probably yes, you will get. So yes. So can interactive apps access Hadoop directly? Nowadays, yes, lot of tools, interfaces we been developed. Yes. Simple example I tell you. We developed a Spring based application. I hope maybe many of you might have heard about Java Spring framework, right? So simple, we wrote a web application. So Spring supports a beautiful web MVC framework. So now we wrote a web application which interacts directly onto Hadoop. So Spring also provides data integration to Hadoop. So any application you write, you can directly access the data which is stored onto Hadoop. Maybe web application I'm trying to refer, right? So let us discuss that as we go ahead, don't worry. But yes, a lot of application directly you can. So PDI, for example, you might have heard about Pentaho data integration, right? So again, all these tools, right? Oracle, ODI, Oracle data integration. So all these tools, softwares nowadays, they started integrating with Hadoop. So simple reason, let me explain now in the future slides, you will understand very well, right? Hadoop is for batch processing only for use for online or only. No, online application we don't use on Hadoop, Ashok. We will see why, and then it is basically for accessing batches of data quicker. So high throughput we say. Hadoop is used for high throughput. What do I mean by high throughput? Let me explain again in detail now, right? So I missed it out. How much data, how much does one node store? Prashant, I hope you are asking about 300 nodes, 10 terabytes data, I said, right? No, I was just giving an example. If Sears has 10 terabytes of each node, right? So it can store up to 3 petabytes of data. That is 3000 terabytes of data it can store, right? That's what I was telling. I was just telling an example. If it is 10 terabytes, it comes to that. Yes, Prashant. So there is no maximum limit for data stored. Exactly, Sharmila. Yes. So when we talk of Hadoop, so there is no limit of cluster nodes, number servers here. So you can say there is no limit of data storage. Yes. Is there any limitation of number of nodes? So we need to understand architecture for this. Maybe limitation of nodes. There are two kinds of Hadoop architecture. We say federated architecture, high availability architecture. Let us understand tomorrow probably. But yes, I can say there is nothing limitation as such. So maybe as have you anyone heard the maximum servers which is tested in Hadoop cluster? Can anyone give some rough figure if might have read or heard about it? Hadoop is used on maximum servers clusters. Can we analyze real-time data? Yes, we can do that. Yes. So Venkat says 500. Anybody else? If data processing requires both online and batch processing, then we cannot consider Hadoop, is it? Yes, we will see that. We will see that. Sharmila. But yes, there is an option now. But I mean to say Hadoop was not developed for real-time processing, we can say. Hadoop was not developed for real-time processing. Hadoop was developed for batch processing. That too, that's where I said high throughput, right? So we will discuss then, that is the limitation, right? So how to overcome that we will see. So to give a clue, that is where we discuss about HBase, right? In HBase, we can do real-time processing of the data. Don't worry, let us see in detail slowly, right? Can Hadoop handle live data now? I mean to say batch backend processing. Yes. Say for example, Twitter data. Tomorrow itself, I will give you an assignment. I will take you through that small steps, so you can see how to stream data which is generated in Twitter, that is tweets, right? So how to stream them to Hadoop we will see. Tomorrow itself we will see. So Saju says 5K nodes, that is 5,000 nodes. Bimal says 4,000 nodes. Yes. So what are these figure? Really nice, Saju, Bimal, and yes, Venkat, you are almost there. So now, so thousands of servers we have tested on Hadoop. So see now when I say 5,000, 4,000 servers, I am referring, I can say Venkat and Bimal. So we are referring, I'm sorry, Saju, right? Saju and Bimal. Basically, when I say 4,000 servers, right? So this was tested on Hadoop 1 itself. In Hadoop 1, we had lot of drawbacks. We will discuss this tomorrow. What is the difference between Hadoop Gen 1 and Gen 2? So though we had lot of limitations and drawbacks, so Gen 1 itself we have tested with 4,000 servers. Can you imagine this? So nowadays, if you see industries, they have more than 10,000 servers also. I mean to say single cluster. Single Hadoop cluster we can say. So let us see this, how can we achieve this, and today, tomorrow, let us try and understand this, right? So let us see first this, what is in detail, what do I mean by Hadoop and storage and compute grid. Yes, Santosh, 10,000 nodes, that is Gen 2 we can say. Is it fine? So when you say 4,000, till 4,000 we tested on Gen 1 itself. Yes, Saj. So first point, Hadoop cluster means group of servers where Hadoop program runs. I hope all of you know this, right? What is Hadoop cluster in simple term? Right. So group of servers, sometimes I refer it as nodes, right? So maybe you can call it as systems, right? So group of servers or nodes where Hadoop programs, we call it as daemons, right? Hadoop, let me say daemons itself. Hadoop daemons, say programs, right? Residential programs run. That is Hadoop cluster. I hope all of you got what is a cluster, right? So now let us understand what is this storage and compute grid. Okay, before we go into actually Hadoop, so what is why you need a distributed file system? That is, now assume you have 1 terabyte of data you want to process using one machine which has a capacity of 100 Mbps, and then it has 4 IO channels, each channel having 100 Mbps. So now how do you process it? How do you come out with time? Maybe if I ask you in minutes, how do you come out with minutes? So now it is per second is being processed. So now you convert this on MB, right? MB per second. So convert this terabytes into MB. How to convert this terabyte into MB? That is 1024 into 1024, because it is 1000. Sorry. I'm really sorry, friends. So now MB is basically 1024 into your terabyte. If you need to convert to MB, it is 1024 into 1024, right? Because 1K terabyte is 1 petabyte, and 1K petabyte is 1 exabyte. Sorry, I think I have gone ahead. So 1K MB is 1 gigabyte. So 1K gigabyte is 1 terabyte, right? 1024 into 1024 MB. So answer, we divide it by 4 into 100. That is 400. 4 into 100, that is 400, right? So that will give you result in seconds. So per divide by 60, you will get in minutes. That is 45 minutes. If it takes one machine of this configuration, it takes 45 minutes to read 1 terabyte of data. Now assume same machine configuration you have 10, and then assuming this is equally distributed across this machine, and then you are processing in parallel data. You want to read in parallel all this 1 terabyte of data, which is split across same file, same size across all these 10 machines. So we can say to read all this 1 terabyte of data, it may just take 4.5 minutes. I'm really sorry, friends. Today, I'm just getting some coughs. So now, I hope all of you understood why we require distributed file system, right? So in single machine, if it takes 45 minutes to take 1 terabyte to maybe read or load, we can say 1 terabyte of data. So if you have a distributed file system which is managing this data itself in 10 machines which has the same capacity, so now you can imagine the speed, right? 10 times faster than this. So Hadoop, right? So Hadoop is a distributed file system. Hadoop is a distributed file system. Again, it is optimized to access batches of this data. So that's where we say it is data quicker, right? So it runs or it loads data or reads data in parallel, right? Batches of data, when I say that it is a chunk of data, we will see in detail now what it is. So what is Hadoop? Hadoop is a framework that allows for the distributed processing of large data sets. When I say distributed, so now you want to read or process, so process also will be distributed across multiple machines and then it will be happening in parallel. So distributed processing of large data across clusters of commodity computers using a simple programming model. So I told you, right, we use Hadoop may not require higher end servers, so we can use just normal computers, commodity computers itself. You don't need higher end servers, and Hadoop uses a simple programming model called MapReduce. We will see in detail. So framework means all of you know, right? Basically library that provides a foundation layer where we can use this to build our application without writing from scratch, right? We can use this framework to build our application without writing from scratch. So it is a library that provides a foundation layer, frameworks. So Hadoop allows for distributed processing of large data sets across commodity computers. It is open source data management with scale out storage. So we have two kinds of storage, that is scale out, scale in, scale up and scale out. Scale up means we are referring to one server increasing the capacity. For example, you have 10 terabyte capacity here, you want 20 terabytes, so you can increase the hard disk here. But it has its own limitation, right? You cannot add terabytes of data if it gets daily generated, so you cannot keep on adding data here. It has its own maximum limit, right? So that is scale up. You are increasing a individual systems RAM or hard disk. But when you say scale out, right, you are just adding the node itself. So there is no limitation here, right? So that's where we say scale out. Scale out is nothing but, say you have 10 terabytes of each. So if you are managing 100 terabytes in this whole 10 machines, you want to manage another 100 machines, 100 terabytes, you just add another 10 machines, that's all, which has another 10 terabytes each. So scale out. So Hadoop with scale out storage, and it distribute the processing also. It is a distributed processing. It uses distributed processing. Right. So probably what is a daemon, Mithun, as I said, daemon you can consider as programs now, just in a simple term. So residential programs, which is, say for example, Hadoop also has made up with some programs, right? So there we in Hadoop we have some of the important programs which will take care of some responsibilities. We will discuss that in detail. How the name Hadoop, any special meaning Hadoop? See, basically Hadoop, right? So when kid. I just forgot name. So elephant was the just toy. It was just referred to the toy when kid was playing around. So the kid was sorry, ducking. Yes. So ducking son was playing with toy. So Hadoop elephant toy. So he just called Hadoop Hadoop. So yes, just named that itself. Yes. Thanks, Venkat. So Jumbo. Yes, Saju. Who decides what chunk of data goes to which machine? We will discuss this, Saju. Yes, we will discuss this now. So, friends, basically, what we'll do is maybe mid of the time, right? Let us take 10 minutes of break and then come back and join, friends. Probably we can take 10 minutes break. Please, can I get yes for break from all of you, friends? Yes, thank you very much, Saju, Kevin, Ashok. Yes, Rakesh, Bijoy, Mayank, thank you very much, friends. Let us take 10 minutes break and then come back and join, right? Probably exactly 9:26 here. So now 9:40 will join, say almost around 15 minutes. So 9:40, let me type it. Break 9:40 will join back. Right, I'm sending it to all of you. Thank you very much. Yes, friends, I hope all of you are back from break. Please, can I get yes in the chat window? Yes, thank you very much, friends. So let me just open up some explanation. Okay, so now when I say Hadoop, right? So Hadoop is made up of two main components. That is, one is SDFS and other is MapReduce. That is, you can also call it as Yarn or MRV2 for processing, right? So there are two main components. One is Yarn or one is SDFS. SDFS will take care of storage and read write of data, we can say, and processing is basically for analyzing the data. So now these two components is made up of, or we can say organized by multiple daemons or programs, we can say. So now SDFS is taken care by name node, data node and secondary name node. SDFS is taken care by name node, data node and secondary name node. Optionally we have secondary name node. So these are daemons, right? And Yarn or MRV2 MapReduce processing is taken care by resource manager, node manager, app masters. So what are these? These are daemons, basically programs which will take care of these components. So what are the main components? File system, where we do read and write of data, which will take care of reading and writing of the data, and Yarn is basically for processing. So two components is made up of these many daemons, right? So now Hadoop, we say master slave architecture. Hadoop, we say it as master slave architecture, meaning name node, right, is the master and data node is the slave for SDFS, and for Yarn, resource manager is master and node manager is slave. When I say master and slave, right, so this master program tells what this slave machine has to do. So it directs what this program has to do. So these daemons will obey master's order. Same way, resource manager tells what node manager has to do. So node manager will obey resource manager's order. That's where we say master and slave, right? So I will come back to this. What is this secondary name node in a while. So now for you, basic thing what you understand is, for SDFS, name node is master. For Yarn, resource manager is master. I hope till now all is fine, right? So these are daemons, basically programs, so which is architected as a master slave. Right? Now, if I say simple cluster with Hadoop daemons, it will be like this. Say now, if you have 5 servers in a cluster, you will see one master and multiple slaves. So 5 is a small number, right? 5 is a small number. That's where we have 2 master daemons running in a single machine. I hope all of you got this point, right? See, now let me explain here. Now it is a small, right? It's not a big cluster what we are discussing. If I give you 5 servers, what you can configure one as master and slaves. One, because it is too small, in one itself you can run both masters, name node and resource manager. I told you this name node is master for SDFS and resource manager is master for Yarn, right? So now that means both master can run in one server, so one machine node in a small cluster, and rest all will be slave machines. When I say slave machine, can you all notice here? I say data node, which is a slave of HDFS, and I say node manager, which is a slave of Yarn or MRV2. Right? So both are slaves. So each machine, right, you see slave daemons are running. Each machine, you will see slave daemons are running. So now one more point. Name node and resource manager can also run in different servers. It doesn't mean master has to run in one server. Say for example, if you have too many servers, so too big cluster if you have, so what you can configure is you can configure name nodes, one active standby, and you can configure one resource manager separately running in a separate masters servers. So meaning for a small cluster, you can also configure in a single server where all masters run. For huge clusters, you may, if you want, you can easily configure all name node and resource manager running in a different masters. And coming back to name node, we have active and standby. Right? So what is the importance of name node? Why we have active standby? Let us discuss later. But anyway, now you can understand a name node can be multiple, like active and standby, and resource manager is actually a one daemon which is running in a single master resource manager. Right? So now when I wrote this, right, group of servers nodes where Hadoop daemon runs is a cluster, that is this, right? So now what are daemons? That is programs, right? What are these programs? Name node is one program, so where it is running in multiple machines here as active and standby, and resource manager is one program, and that is, these all are master daemons or servers programs, and here node manager and data node are slave machines running in each slave machine. Right? Is the secondary name node a master? Yes, we call it as master. Iqbal, I will come back to that. Yeah, secondary name node in a very soon time. Right? Will master also store data? No, never. Right? So it never stores the actual data, but it stores the metadata. We'll discuss that. Right? Will all the slaves always have data node? Exactly. Yes, data node plus node manager. All the slaves should have both of this. Right? So what is the purpose of standby name node? Yes. We'll go one by one. We'll see that, Rajesh. Now we will see what it is, why we require active and standby name nodes. Right. So first let us understand what is the role, what is the importance of this name node itself. Then we'll come back what is active, standby, name nodes. Right. So now I want you to understand, I hope now all of you understood this, right? What is Hadoop cluster? Hadoop cluster means, in simple, 5 server cluster means this. All Hadoop daemons running in multiple servers. We call master and slaves. Always remember, slaves will be many compared to masters. Master may be each daemon running in a separate machine. So maximum this, you can take it 3 masters, but you can have n number of slave machines. So now you see, masters will have RAM more, hard disk less, and slaves will have hard disk more compared to RAM. So now 16 GB RAM with 12 terabytes, that's where we can, okay, coming back here. So now 16 GB is RAM and 12 terabytes. So that's where we said we can use any commodity computers, right? So this can be your server in your Hadoop, which we have configured as slave. So now whatever data you move to Hadoop, that means this cluster, data will be always stored on slave machines. Data will be always stored on slave machines. it never be data, actual data like user data will never be stored on this master nodes. Actual data will be stored always on slave machines. And which data stored where, that is metadata, will be maintained by this name node. So name node takes care of Hadoop distributed file system, that is the master node. So it knows which file is stored where in the cluster. And also it tells where it has to copy, which nodes it has to copy data. Everything is decided by this name node. Right? So now how it decides, where it stores, everything we'll see, understand now, right? Now you see, you need to understand this. Now in Hadoop 1, right, block size was 64 MB. In Hadoop 2, block size is 128 MB. What is this block size? Meaning if you copy any file to this Hadoop cluster, file will be split into blocks. Maximum size of 64 MB in Gen 1, 128 MB in Gen 2. That means assume you have this 200 MB in Gen 2. What happens is 128 MB plus balance, right? That is around 62 MB, right? Or 128, that is 72 MB, right? So balance 72 MB, 2 blocks will be created on Gen 2. If you are using Gen 1, 4 blocks will be created. What are blocks? Blocks are nothing but physical data, right? And this data blocks are distributed across multiple nodes like this, right? So now let me explain this way. Maybe instead of 100, so let me take up PPT and then explain. Yes, I've already done. See, now I want all of you to understand this point, right? Yeah, let me explain this. See, now if you have 200 MB data, say for example sample.txt, when you copy to Hadoop, first point what you need to understand, data will be stored in data node, slave machines only. Data will be stored only in the slave machines, right? So next, data will be split based on block size. Default block size in Hadoop 2 is 128 MB. So data will be cut into 128 MB physical blocks as physical blocks. So now for 200 MB you will have 128 MB plus 72 MB block, right? One more step further, each block will be copied into 3 replications in the distribution. That means each block will be copied as a replication 1, 2, 3, and then it will be spread across in the distribution. Meaning for 200 MB file you have in total 6 blocks. You might be wondering, right? First of all, we are talking of big data. Hadoop manages big data, and then Hadoop, what it is doing is, it is again creating 3 replication for each of the block in this file, right? So that means you can imagine 200 MB data is occupying total space of 600 MB. Why? Because we have 3 replication for each block, right? So now one important point you need to understand here in this conversation, that is each replication will be always stored in different machines. Each replication of a block, right, will be always stored in different machines. Meaning, in other way, if I have to tell, so multiple replications of a single block will never be copied onto a single node. That means B1 R1, B1 R2 will never be in a single machine. So that's where you will see B1 R1 is here, B1 R2 is here, B1 R3 is here. So B2 R1, B2 R2, B2 R3, you see they are all on different machines. Meaning replications will always be copied into different machines. So why? Because if you lose any nodes, right? So Hadoop will know still where to read the data from. So that means Hadoop keeps 3 replications by default for each block, and then that is used for fault tolerance. Fault tolerance means, as I said, Hadoop uses commodity computers, and we say we can create n number of servers. You may expect some of the servers may go fail, right? So what happens if you lose some of the slaves, right? So if data is not replicated, you lose the data, right? So Hadoop intelligently what it does is it replicates and then keep it on different machines. Replications of a block, it keeps on different machines. For example, let us assume now Hadoop wants to read this file. So this slave is crashed. Assume this slave 1 is crashed. So Hadoop knows now block 1 it can get from here or here, and block 2 it can get from here or here. Right? So now what you need to understand, when you have to read this file, right, you need to read block 1 and 2, meaning any one of the replication is read. When you read any one of the replication, it will read, or when you process, any one of the replication will be processed for a block, meaning all are same copy, right? So now there is nothing called original duplicate here. All replications are same. When you want to read, you can read either this or this or this from the cluster. So Hadoop reads, instead of you can say you can read Hadoop, if you read Hadoop reads any one of the replication from these blocks. Or when you want to process, it will process either this or this or this. So for example, now you want to read this sample.txt, Hadoop may process this for block 1 and this for block 2. So one replication from block 1, one replication for block 2. Again, it depends on processing or you are reading, right? It depends on which their machines are free or available node. Data node is free to read, write. So it depends on that. So name node, if you just say read, name node will tell data node to read from this data node to read from this, based on availability of data nodes. So maybe they may all busy with some other work, reading and writing. It checks which node is free based on data availability, and then it may assign that itself. So now conclusion is any one of the replication is read, right? So now I hope all of you understood this, right? So please let me explain again one more, all this as a steps points, then let me take up questions, right? Please hold on with your questions. Probably I have hidden this question window. I'm not able to see your question window. Let me explain and then come back and take up your questions, right? So before I go to explanation, let me explain this point. First, before we go ahead, so I want all of you to say yes for these 5 points, right? So data will be stored and processed only in slave machines. That is true. That you understood now. So file will be split into blocks. So 128 MB maximum size, which is configurable. That means this block size can also be configurable, right? So now let me increase this. Now it's fine, right? So now first point we have understood, second point we have understood, right? So when I say block size can also be configurable, right? So now each block is replicated into 3 times. We call it as replication factor, which is also configurable. right? This point all of you understood. So each replication is written in separate slave machine for fault tolerance. I hope all of you understood. Now finally, when you process or read data, any one of the replication will be considered for a block. So first, let me take up questions on this if you have anything. Don't go beyond this because I am going in a flow, right? Probably if you understand this, right, please tell yes, or you can ask me queries right now, right? So let us go further slowly one by one step. So these are basic things what you need to understand before we go ahead, right? So first what we understood what are the daemons. What do I mean by cluster? Cluster means daemons, and data will be all after that. All the daemons after you understand that name node, data node for HDFS, and the resource manager and sorry, and resource manager and data node for processing, resource manager and node manager for processing. So now we are seeing these points, these 5 points, right? Please ask relevant questions. Let me answer. Prasad Gangan says understood. Fantastic, friends. Fantastic. So let me take up. Resource manager is a job tracker. Probably yes. We will come back to that, Kevin. Yes. So Gen 1 we had job tracker, resource manager. Don't worry. Today, tomorrow, maybe again yarn we will see next week in detail. So let us first understand HDFS component in detail today, tomorrow, along with architecture and configurations, right? So number of replication predefined configuration, yes, Avik Yadav. So I think now you understood. So now we can also configure this, right? So number of replication, yes, fantastic. How Hadoop decides which replication has to be read? So that is based on availability of the data nodes, because they might be busy doing some other read, write, whatever. So now, and proximity also. So which data node has to read, so has to be decided by proximity, and then data availability of the data node, right? So name node decides that. Active name node decides that. So if this is free, this is near data it has, so this is free, it may assign this. So it is also possible that, so please try to understand this point. It is also sometime you can say this data node is assigned to do this read and this read, because there may be all other nodes, data nodes may be busy, right? So I hope all of you are slowly getting it right. So in case we want to store 1 terabyte, then Hadoop requires 3 terabyte. Fantastic. Yes, Santosh. Yes. In Hadoop, total capacity we require is 3 terabytes. Fantastic, Santosh. Yes. Please let me know if it is name node responsibility as to which data node what data needs to be put exactly. Yes, Sharmila. So we will see read and write path, how it decides everything. I will explain in detail. But yes, now you can understand that way. So name node decides which data nodes. Say now, assume you have so many data nodes, right? So now if you put on small data, so where it has to write, who knows, right? So now name node decides that, which data node. Yes, fantastic. Point number is to configurable or fixed, that is configuration. Configurable. Gen 1 or Gen 2, both it is configurable image. What do you mean by configurable? You can change. Syed Iqbal, sorry. So now you can change 128 MB to again 64 MB or whatever. So if you have Gen 1, if you have 64 MB, you can configure to one more. So is it always 128 MB, or we can have 2 into 100 MB? Basically, we go on like 64, 128, 256, yes, like that, Gagan. File system blocks, we go like that, right? What if the split happens on the data record off of the, yes. We will see this, we call it as record split, right? So Pulkit, record split is to deal with again processing environment. So record split will happen. That you need to understand here at this today's point of time. So when I say split of the data, right? So when I say data will be stored, data will be split into blocks, record may be split from one block to another block, half of the record may be split. That much you understand. But now when we process or read data, we have to worry, right? How to read from multiple blocks, we will see later. Is it fine, Gagan? But yes, you are correct. So I think it is Pulkit, right? Yes. So replication 3 is the minimum factor. No, we can configure 1 also. 1 also, Mithun. Yes. So 1 also, maximum 255. But anyway, maximum anything you can configure. We may not go so big number, but yes. So many times we leave as it is. Bijoy, Mithun, Raja. We many times we'll release. We rely on Hadoop's default replication factor. So what is the maximum? Maximum basically you can go till 255, but anyway, so we don't need to worry, right? So many copies, we don't need to worry. So that means, see now, replication, I told you it is for fault tolerance, right? So fault tolerance replication, say now data, it is stored here in multiple machines. So now 1 or 2 machines, if it fails, see here, assume this machine also failed. So now again we can get block 1, block 2 data from rest of the machines. So we don't assume in a distributed fashion, we don't assume all the 3 slaves die, crashes at a time, right? Some of them may fail, right? So what is the standard replication factor? I think yes, Shivananda, 3. Reading replication date name will name node will assign one node one block at a time. Reading replication. Okay, so now we will see that, Ashok, we will see read and write analogy in detail now. How it reads, how it decides, how it reads from replication, we will see. But can I get yes for this point, friends? Did you all understood? When you want to read or process the data, any one of the replication will be considered. Can I get yes from all of you, friends? I hope this is simple, right? Because all are same copy, right? Fantastic. Thank you very much, friends. Yes. Yes, Sharmila, Yogi, Pulkit. Yes, friends. Gagan, Prasad, Kevin. Fantastic. Radesh, Santosh, Iqbal, Avik, sorry. Fantastic, friends. So one block store in one machine. So here we use 6 machine. I am right. One block store. So now you see here, each block replication only is distributed. Not maybe you see here 2 blocks are stored here. Maybe different blocks may be stored in a data node, but replication of a block may not be stored in the machine. Did you understood this point? Replication of a block. So that means B1, R1, B1, R2 will never be in a one machine. Is it fine, Kevin? Now, did you understood this point, Kevin? Yes. I hope I have answered all of your queries. Please, if I have missed some of your questions, right, please do ask, right? So what happens if name node crashes? We will come back to that, Yogi. So that's where we have active and standby. We will discuss that. Is it client software also works on Hadoop for downloading files from Hadoop? Is it? We will see that, Santosh. How to just download from Hadoop, you are asking, right? So we will see first how to just we use Hadoop copy commands itself, right? Shell based copy commands. We'll try to understand that, right? Today, maybe tomorrow, we will see all these details. So is there any number of minimum data nodes which can be used? See, now Hadoop can run in varied configurations. You can have only one machine where all the daemons runs. We call it a pseudo distributed mode. Only one machine. Maybe you want to learn Hadoop, right? Now I said this VM we are giving, right? We are distributing this VM. So now in this VM you have configured pseudo distributed mode. That means you just go to your terminal and say sudo JPS. You can see all the daemons running here. Node manager, data node, resource manager, right? You can see node manager, sorry, we can see name node, data node, resource manager, node manager, right? So we also have history server. We'll discuss this later. So now you are seeing this, right? Don't worry about secondary name node. We'll see that later, right? We'll discuss that later. So that means, okay, I'm sorry, I should have explained this. That means we are running all the daemons in a single machine here in the local machine, Linux machine, right? So this is CentOS machine where all these daemons are running. So now Hadoop is configured. This is called pseudo distributed mode. PSEUDO, pseudo distributed mode. Tomorrow we'll discuss this in detail, right? So now starting from one machine you can have multiple, but I suggest minimum you want to enjoy Hadoop, you want to just observe, so you should have at least 5 servers like this, right? Because five so at least 4 data nodes you will have as slaves, so that data will be distributed. These 3 duplications will be distributed across multiple machines, right? Let us go slowly further. I hope some of the important points we have understood, right, about Hadoop, right? So now fault tolerance in Hadoop, how it happens? Because each block is replicated 3 times and it is written, each replication is written in a separate slave machine. So that is, if you lose 1 or 2 machines, you still have data which has to be reconciled from all the blocks, right? We can reconcile from for all the blocks. So that is where we say Hadoop maintains fault tolerance. Now let us see what are the key characteristics of Hadoop. So that is, Hadoop can be reliable because we say it is fault tolerance. It does fault tolerance. You copy a file, it sorry. So it take care of fault tolerance. So that's where we can say Hadoop can be reliable. So each block of data is distributed, right? Replication, each block is created as replications and distributed. So we can say reliable, right? And economical, basically commodity computers we use in Hadoop. So that is the reason we can say Hadoop can be economical, right? So that's where actually if you see Hadoop as popular, become so popular in less time because of this characteristics, because we all know now anything economical, I mean commodity computers with anything open source free softwares, and if it is good we never leave it, right? So Hadoop economical and scalable. As I said, you want to increase data in Hadoop, you are getting increased data, right? So you just have to increase nodes, that's all. Without changing any configuration of Hadoop cluster, you just add nodes, so it will start taking extra data. That is scale out. So we say scalable and flexible. So now big data, when I say, we talk of data which is coming from multiple sources, right? So Hadoop, we say it is schema less and can observe any kind of data, structured or not, from any number of sources. That's where we say flexible, right? And compared to RDBMS, right, difference between Hadoop and RDBMS, if you see, Hadoop, we say it maintains structured data types. I already said database stands as a gatekeeper, validates entire data before you write. So that's where we say schema on write for RDBMS. That's where it is structured data. It maintains structured data, right? Schema, it verifies before it writes itself. So that's where RDBMS we also say schema on write. But in Hadoop, as I said, any file, right? TSV, CSV, XML, JSON, image files, audio files, you just move it on to Hadoop. So Hadoop, when I say this, just multi and unstructured, I am referring to file system, Hadoop distributed file system, which is managing of files, right? So any size file, you just move it on to Hadoop. What happens? It get splits as blocks and then it will getting distributed. And processing is coupled with data. Now let me explain this little bit and then before we go ahead. Now you see, when I said data read write, I am showing you this slide. Data read write, I am showing you this slide compared to this. This, when we say process, we discuss about this slide. Why? Because we have resource manager and node manager which takes care of processing. Read, write, we have name node and data node which takes care of read and write. Right? So now let us come back here. I told you already, if the block data is like this, and then when you want to process, again any one of the replication is assigned for processing. Like when you read, any one of the block replication will be read. So same way here, any one of the replication will be processed also for a block. Now assume this resource manager decides it has to process this data and this data. Right? Assume now resource manager decides this data and this data in this servers, let us process this data. Now when I say process, right, you need to write program and submit to that to process. When you write program, you will be writing MapReduce programs. So those MapReduce programs will come to this slave machines and execute on this data. Did you all understood this concept, friends? Whatever you write, I told you when you process means you will write MapReduce programs, right? That is MapReduce. So now when you write MapReduce means you will write actually MapReduce program, Java program. So when you submit that Java program to process data, so if Hadoop based on data availability, if it takes this, so your programs will come to this node and executes on this data. Rather, data moving out, programs will come to this, program will come to this, and then they will get executed in parallel. Right? Please, can I get once again yes for this program coming here and executing in parallel, friends? Fantastic. Thank you very much, friends. Is there any maximum size limit of data node? Nothing. Basically, based on configurations. But anyway, yes, in actual production, Sharmila, we try to manage all name nodes as same configuration as much possible, because I don't want to increase RAM here, reduce here, so processing will get effect, right? So RAM disk is considered, as far as configuration is concerned, we'll try to manage all same configurations. If I have 2 machines implement cluster, yes, you can do that, Yogi. But actual production, at least minimum, if you have 5, that will be good. Gagan, please explain flexible, is it? See, now this Hadoop, right? This Hadoop, any data, you just copy it, it gets distributed. So that's where we say Hadoop can observe any kind of data, whether it is structured or unstructured data, and it can read data from any number of sources and then store it here. That's where we say flexible. So friends, Gagan and friends, if I am showing this diagram, what is the capacity by keeping in mind? So now let me show this, come back here. I want all of you to answer this query. That is, now you see here, I have 4 slaves and 1 master. What is the storage capacity, total storage capacity of data here? 12 into 4, 48, right? 48 terabytes, 12 into 4, 48 terabytes. So can I get a quick answer from all of you? What is the maximum size of a file I can move it to this cluster considering 3 replication factor? Fantastic, Anand. Fantastic, Gagan, Venkat. Yes, Bijais. Very nice. Yes, Santosh, Shivanand. Nice. It would be challenging to keep 4,000 nodes with the same exactly. Probably yes, Anand. Yes, that is true. So, but anyway, already see now that is true. I'm not talking of 2 big clusters maintaining years together. Yes, we need to change. So yes, probably we upgrade also, right? Yes. So I have got Bimal also answered, perfect. So now 16 terabytes is the perfect answer, right? Is it fine, Yang? It is fine, Iqbal. 16 terabytes, because see now 12, that is 12 into 4, 48, divided by 3 replication factor will give us what is the maximum size of the file, right? So 48 divided by 3, 16 terabytes. Please, can I get yes, Yang, Iqbal? Is it fine? 16 terabytes is the answer. Sayed? Yes, Himanshu. Fantastic. Vivek, can you repeat? See, now I said, okay, let me explain this way. See, now I said 1 terabyte of data, right? So, okay, let me tell like this. I have a file called, say, employee.txt, not employee, maybe weblog is best. So, weblog dot maybe again txt file. Say I have around 16 terabytes of data, right? So now when I say each block, right? So what is the number of blocks here for this file? That is 16 terabyte divided by 128 MB. So you terabyte you convert into MB divided it by 128, right? So 16 terabytes you convert, first we need to convert this into MB and then divided by this much, so this many blocks. Now I said that is this many total blocks. So now I said each block is replicated into 3. That means now 16 terabytes will be taking into 3 spaces, right? So now multiple 3. So that is resulting in 48 terabytes, right? Now I hope all of you understood, right? So 16 terabyte file if I have, I can, that means it takes into 3, that is 48 terabytes so of space. That's what I was asking. So if it is 48 terabytes in total, so what is the maximum file size I can move it? Now I hope all of you understood, right? Vivek, is it fine now? Thank you, Vivek. Yes. So now we saw what is processing coupled with the data, right? Data wherever it is, so our program goes to that node. But in RDBMS, data used to move to the processing layer, right? So RDBMS standards, we have a lot of standards and structures. We have key, primary key, we have foreign key, we have indexes. So with these indexes and primary key, foreign key, we can do row level updates, deletes. But yes, in Hadoop, it is, we say loosely structured, so we don't follow anything standards and structures as far as data is concerned. Whatever data it is, unstructured, semi-structured data, we just copy onto Hadoop. That's all, right? So now schema required on read. So when you write data, Hadoop never checks what you are writing, but you want to read, it will see what kind of data you are reading, whether you are reading string, whether you are reading integer, it checks when you are reading, but when you write data to Hadoop, it never checks. So that's where we say schema on read, but RDBMS, it checks when it writes itself, so we say schema on write. And Hadoop speed, when you consider, basically, again let me repeat this statement, HDFS is optimized to access batches of data quicker, that is high throughput, rather than particular record in that data set. Low latency, we are not talking of Hadoop. So write, what happens is, assume you have some data, say 1 terabyte of data. So now you are writing it. So 1 terabyte of data will be split into blocks, and blocks data will be written in parallel into the Hadoop cluster. That's where we say write is fast. Did you all understood this? When I explained about reading of the data here, right? Reading of the data. So if you have data split across, so reading, or I can say processing, loading, when you say processing, I can say this data will be processed in parallel. So we access data in parallel on this block size batches of data, right? Sorry. So now that's where we say when it is read of entire file, whether it is read or write, Hadoop is fast. Please don't get confused. I am saying write is fast. That doesn't mean read is slow here. I am referring to entire file. So read is fast here. But reads are fast when I say in RDBMS, I am referring to particular record in the data set. So basically many processing environment apart from analysis on entire data, you may want to fetch particular record, right? So that is fast here in RDBMS, but you cannot fetch a particular record in RDBMS. But as far as reading entire file is concerned, Hadoop is very fast. So I hope all of you understood this point. Speed, as far as entire file you read or write, Hadoop is fast, but only record level fetching, Hadoop is fast. RDBMS is fast, which is not, Hadoop is not designed for low latency applications, real-time applications, right? Record level, row level updates, deletes, fetches of data, we cannot do here. When I say we can also do it by other, other way by using some NoSQL databases or some processing framework like Storm. So all those things we'll discuss later. But Hadoop is designed, basically designed as optimized to access batches of data quicker. So that's where we say read, writes are all fast here. Right. So now cost, again Hadoop charges just support costs. As far as distributions are concerned, so now what are we discussing here? So now we have just Apache software what we are discussing, right? So now Apache is the open source Apache Hadoop is what we are discussing, right? Version 2.2.2 in our VM we have installed this, right? So anybody can use this open source, download, install and create their own cluster. So like this, now if you see, Cloudera is the company where they have their own distribution called CDH, Cloudera distribution for Hadoop. Like they had 4, 5, so now 5 version is the latest. Like that, now if you see Hortonworks, they have their own distribution, right? MapR, they have their own distribution. Again, you see IBM has its own distribution called Big Insights, right? So Microsoft have their own distribution called HD Insights. Right. So like this, based on this open source, these companies have taken them and then built around the, again, distributions. Maybe they might come out with a lot of supporting packages and it might be easy compare installation and then using them, because raw Hadoop, if you download, you need to configure yourself, you need to ecosystem products, you need to install yourself, lot of things you may have to do on your own. But if you are using these distributions, it may be fast, right? It may be easy to install. So that may, we say, bundle of Hadoop related projects they might have bundled. Lot of Hadoop related projects they might have bundled to you, so it may be easy for you to use this kind of distributions from companies. But yes, they might charge only for support. There is nothing called so-called charges for the distribution itself, right? But RDBMS, we add software license cost and resources. As far as RDBMS is concerned, known entity, which resource we are reading the data, where we are storing the data, where we are getting the data from, it all known. It should be known, because we said schema on write, it is structured data, so it has to be known here, right? So for you to define everything before in hand, so now you need to know the resources. But here we don't know the resource, what kind of data you are getting. That's where we say loosely structured, it can maintain unstructured data. So data itself, like growing complexity and wide here, any kind of data, right? Sensors used to gather climate information, you can just use Hadoop to store. Posts to social media sites, you can use Hadoop to store. Cell phone GPS signals, you are getting lot of data, you can use Hadoop to store. Sensors data, you can use Hadoop to store, right? So now best fit use case, data discovery, that is huge data we are storing here, so data mining, we can call it as data discovery, right? So Hadoop, we can use it for data mining, processing unstructured data. So conclusion, massive storage and processing, Hadoop we can refer. As far as RDBMS, we know now it adheres to ACID property, that is atomicity, consistency, isolation, durability, all this. So now OLTP is where we can use it, Hadoop. So online transaction processing, where Hadoop may not be fit, right? So RDBMS is good for OLTP. So operational data store, that means row level updates, deletes you want to do on data stored. So now you can use RDBMS. Better, right? Better choice is RDBMS, right? So we can add on the fly, or we need to have a maintenance window. Probably no, but again, administrator has to run a small software called load balancer. So when you add some new nodes, right? So all those new nodes will be empty. So now administrator will add some tool called or program called load balancer. So name node will balance the cluster to the new nodes. So nothing we need to have stop it for just adding new nodes, right? Is it fine, Shivana? So Hadoop is a framework that allows for the distributed processing of, if you have these two choices. So now I prefer large data sets, because small data sets anyway we used to manage this in typical RDBMS environment and then process, right, without any issues. Last these 3 decades, you can see any data, what you used to do, you used to just move it on to any typical RDBMS, and then we used to process that, right? So large data set is the preferred answer. So it is capable of processing small data sets. However, to experience true power of Hadoop, right? True power of Hadoop, so we need to have data in terabytes, because this is where we face challenges in RDBMS, right? So now this is typical Hadoop architecture, or sorry, ecosystem. What is ecosystem is basically software project built around Hadoop, each addressing a variety of problem spaces and meeting different needs, right? So now we have here, you see, notice here we have MapReduce framework and SDFS here on as a Hadoop components, right? And rest we have HBase, Hive, Pig, Mahout, Oozie, Flume, and Scope, right? Same way, if you compare here, just modification is SDFS bottom layer we have, instead of MapReduce we have Yarn here. Means to say, in Gen 1 we had only MapReduce framework to process the data. In Gen 2 we have Yarn in between, where through Yarn we can have multiple processing environment we can create based on top of Yarn to process the data. So that means MapReduce has become one of the processing framework in Hadoop 2. That is the major difference between Gen 1 and Gen 2. In Gen 2, we have n number of processing environment, massive message passing interface, Giraffe to process graph databases. So they are all processing environment, Storm, Spark, right? So all these tools you might have heard. So that is works on top of Yarn, not here, because Hadoop was supporting only MapReduce. So here MapReduce is one of the processing framework, and again we have Pig, Hive, Mahout, all these tools here also. So ecosystem. So as a developer, you don't need to worry if you learn So whether you need to learn extra things here, no. As a developer, all these tools are same year and year. Maybe as we go ahead, we may add with a lot of libraries and additional features. Other than that, basic things works fine with both the environment. As a developer, you don't need to worry. So now if you are learning MapReduce, it is same as here also, right? So now Hive is more kind of a data warehousing environment built on top of Hadoop. So now that means you can analyze the data which is stored, huge data which is stored on Hadoop, right? So that is data warehousing. You cannot do row level updates, deletes here. Data warehousing is not good for transaction processing, right? So it is basically for querying and analysis, data warehousing. So now we can use SQL based queries itself in Hive. So if you already know SQL queries, you don't need to learn anything new here. You can straight away start processing the data which is stored on Hadoop. That is the beauty. That is the advantage, right? So in Pig, we say Pig Latin, we use that is a language name. Again, you don't have to worry whether you need to learn a new language here or what. It is just some of the commands. So when we see, you will definitely appreciate it, right? So again, Mahout is a machine learning language. Machine learning tool, we can say. So broadly we have three categories: recommendation, classification, clustering you can do on Hadoop. So that is using Mahout. So you don't have to write any algorithm on your own to do recommendation engine. You can use Mahout itself. So why I have written all these tools on top of MapReduce? Because all this again will convert our queries or processes into MapReduce, commands, queries into MapReduce, and then internally they run MapReduce itself on top of this data. So when I say Hive, Pig Latin, though I don't need to worry about Java MapReduce, so they internally convert. That's where we have them on this MapReduce framework. So conclusion, this MapReduce, Pig, Hive, Mahout, all tools are there to process the data which is stored on Hadoop. Now HBase, NoSQL database. So now why we call it as NoSQL database? Why we require, first of all, database on top of Hadoop? Everything we'll see in detail, right? So it takes a lot of time. So let us not worry too much today. So today you just understand it is a NoSQL database, again built on top of Hadoop, right? So now if you have multiple jobs, you want to define a flow, you can use Oozie. Say you want to run some couple of MapReduce jobs on a data, and then output again you want to run on Pig. So Pig's output you want to run on Hive. So now you have to define a flow, you can use Oozie. Oozie can also be configured as configured to run this workflow at regular intervals. So we can call it as Oozie can also be used as schedulers like cron jobs, right? Oozie can also be used as cron jobs. So bottom layer we see here Flume, where we online stream data. You want to stream data which is getting generated in real time. Best two examples I will give. One is weblogs. Assume you are creating weblogs from multiple websites. You are creating weblogs, so that has to be taken online to the that has to be streamed online to the SDFS. You can use Flume. Second example, Twitter. I told you per second more than 5,000, 6,000 tweets gets generated, right? So you want to map Flume to stream that Twitter data and then move it on to SDFS. You can use Flume. Tomorrow I will explain this. Maybe I'll give an assignment tomorrow itself. When you are ready with VM, you can try and see this, how to stream data from Twitter to Hadoop. And Scoop we used to do import and export RDBMS data. That is Oracle, MySQL, MS SQL data you want to import to RDBMS or export from Hadoop to RDBMS. So now you can use Scoop. Right? So how does Cloudera Hortonworks differ from original? I told you, right? They might have a lot of supporting packages. They might have bundled all Hadoop related projects. They might be easy to install. So now Cloudera may have Impala, all other tools. Maybe again they use their own tools to process the data, right? So Hadoop, Hortonworks, they may have their own tools. They may, example, as I said, Cloudera has its own Impala tool. So something like this, they might have different tools, processing, supporting packages, you can say, Yogi. So how are you going to store data into Hive from HDFS? So when I say Hive, again, it is stored on HDFS itself. We will see that in detail, Yogi. When I say Hive, so Hive will be stored on HDFS itself. Why HBase is shown outside and is Hive slow? Okay, so now this discussion we will do later. Don't worry, because it should have kept as it is here. But anyway, many times we use Java APIs to access the data rather than MapReduce. So, but yes, we will see in detail. You need to understand a lot. So we'll see the detail of that, Prasad. Don't worry. So in Hadoop to MapReduce on run of HDFS with the help of Yarn. Yes, Yarn is the basic. So now MapReduce also you need to configure. So Yarn it uses as Yarn components. So MapReduce runs on top of Yarn components. Yes. Is it fine, Bijay? What is Spark? Yes, we will discuss this, Shivanand. Maybe I think Yarn we will see next week, next Saturday we will discuss this in detail. Is Piglatin like R? No, R is an analytical engine, right? So Piglatin is simple query based, command based language, right? Your SQL based query. Like your SQL based you can write, but it is not equal to SQL, Gagan. So as I said, Mahout, you can do recommendation engines like LinkedIn uses Mahout. So if you upload your profile, you see companies you may want to follow, it may list, jobs you may be interested in, it may follow, right? So that is recommendation. It may comes with a recommendation based on your profile. Whatever your field technologies and then projects. So based on your profile, it understands and then so it might give you references for companies through recommendation engines. So writing intelligent applications using Apache Mahout and Hadoop and MapReduce magic in action is Apache Mahout. Right? So we have covered this, right? Two main components. One is HDFS, which takes care of storage, and one is Yarn, which takes care of processing, right? So Yarn as resource manager as master, node manager as slave. So HDFS has name node as master, data node as slave. So we also have something called secondary name node. Let me come back to this point now, right? So again, multiple servers, we call them as slaves, these as slaves, and then this is master, resource manager and name node. So this side all Yarn, this side it is HDFS, right? So I hope slowly you are getting it right. Two main components, daemons, master, slave, right? Once you understand this, then you need to start with these points, right? So all these 5 points, then again we will see one by one. We'll go ahead. When I go ahead, I will come back to this and explain in detail, right? We say name node as master of the system. Why? Because see here, when you move a file, when you copy a file to Hadoop, I told you what happens. It splits them into blocks and the replications again moves. Can we imagine? I told you thousands of servers you can have. Can we imagine so many files distributed? So you might be wondering who will maintain which file is stored where. And in each file, again 3 replications, right? So each replication also where it is distributed. How will we know, right? It is challenging, right? So now Hadoop maintains everything inside this name node. So basically name node is the daemon which will maintain these files and directory structures of Hadoop. It is like a tree-like structure. So now you see file name, which file, which block, which replication stored in which slave. It is like a tree-like structure. So each file, each block, each replication is stored in which slave. For example, you see here B1, R1, S1 is stored here. B1, R2, S2, it is stored here, is slave 2, right? So now B1, R3, it is stored on S4. So like this tree-like structure, we call it as namespace. In Hadoop, we have some terminology called namespace. That means, sorry. So namespace, that means nothing but files and directory structures of Hadoop. Right? Files and directory structure of Hadoop. So there is no replication of name node for fault tolerance. Yes, we will come back to that, Gagan. There is nothing replication. So this is metadata. Metadata, so we call it as namespace. So it is not actual data, right? It is data about data, metadata. So now, so that's where we say master. So now you might be wondering, if you lose this, what happens, right? Assume you have only one name node like this. Assume you have only one name node server like this and data you are stored here. Do you think if you lose the name node, you can access where it is, where the data, where it is? Do you think we can access the slave machines? Actually, no. If you lose name node, that's all. Your entire cluster you will lose, because name node only maintains complete namespace of the cluster. That means files and directory structures. Right, namespace. So for quick answering, name node keeps all this namespace details in RAM. So that's where we see in the cluster configuration, I might have written RAM size more for name node. And because name node is very, very important, so we have active and standby name nodes where this RAM namespace is maintained between them. Namespace is stored here also and here also. So if you lose this name node, you can actually Hadoop can use this as active to serve the purpose. That's where we should have active and standby name node in Hadoop cluster. So we call this as high availability. We call this as high availability. High availability means when you hear this word, right? So now I am introducing a lot of terminologies. That is namespace, right? Namespace means files and directory structures. Right? So now, what did I say now? One more. Namespace, then I wanted to write something else here. I just forgot. Okay, so now namespace means files and directory structures here, right? And metadata is the namespace. You can also call it as this metadata, files and directory structures. That is metadata. Okay, I wanted to write high availability, what it is, right? Fantastic. Yes, Bijoy, thank you very much. Yes, Gagan. So now the word you forgot. Okay, okay. So high availability means now high availability means we have active and standby, you can use standby name nodes which share status of cluster, that is nothing but namespace, right? So active on standby name nodes, high availability. When you hear, so probably tomorrow we'll touch base this again, this how this high availability is maintained between two servers. We will see tomorrow. So metadata is more or equally important than data. Exactly, yes, Gagan. So now all of you understood, right? So is namespace always stored in RAM? Exactly, Avik. So namespace, again, metadata so always be in RAM. And one more important point, name node also saves files, this details into files called fs image and edit logs. So when you start cluster, right, when you start cluster, say something like this, so now all existing data structures, right? So now, for example, when I say class start cluster means, you can say you might want to stop this server for maintenance and then start again. So there are two things, right? Once first time you will be starting the cluster, and when you start using this cluster, maybe for some maintenance you shut it down and then you start servers. So whenever you start name node, entire file system snapshot will be taken, that is fs image, and then on the go when you are adding deleting files, that will be edited, that will be saved onto this file, edit log files. So these two files this name node manages, other than this namespace which is always there in RAM. Fantastic, Vivek. I hope you are getting it right. Nice. Is it fine, Avik? Yes. So now that's where we say name node is very important, and then name node we call it as master, because not only storing this namespace and metadata, so it also guides where to write data to. That means which nodes, that is slave machines, right? Which slave nodes I will write to be chosen to write data, right? Guides where to write data. That means which slave nodes to be written letter to, that it writes. And then because of replication, it also guides where to read the data from, because any one of the replication we need to consider, right? Of block, any one of the, right, any one of the replication for a block we are discussing, right? So that is also decided by name node. All this responsibility is done by name node, but data node is just to read and write, that's all. So it tells you write this data, data node obeys master's order. It tells you read this data, data node reads this data. So that's where we say name data node as slaves and name nodes as masters, right? So name node master of the system, and maintains, manages blocks which are present on the data nodes, right? So now name node is very, very important. You should make sure at least only this server is good and higher end, and then it runs in a always in a good manner, maybe power backup, right? So all these things you should take care of this master daemon very well. If this master daemon itself fails, so you will lose the cluster. So that's where you will see this Lamborghini car here. Not only buying it, right, you need to manage it, right? So that is name node. Higher end configuration you may choose, and then you need to manage, maintain it. So as far as data nodes are concerned, commodity computers we can use. So this is only one, so we don't mind it in a huge cluster. So yes, as far as data nodes, you can use normal Ambassador cars right here. So slaves which are deployed on each machine and provides actual storage. So I told you always keep this in mind. Data will always be stored onto data nodes and processing will be done at the data nodes only. Right? And responsible for serving read write request from clients for the clients, right? That is data node actually does reading and writing of the data. So now name node metadata, that is namespace, right? So metadata maybe which folder, which file, so which how many each replication stored on which slave, entire details it stores. So stores metadata only, not user data, right? So it stores only not business data, I mean to say application data. So it stores only metadata, that means data about that data. So keeps track of overall file directory structure and placement of data block. That is the responsibility of name node, main responsibility of name node, and it keeps everything in main memory for quick response. Because see, now you have this kind of environment. So now all request, because all many servers we have, so all request comes to this name node only. I want to read file, name node has to tell where he has to read. I want to write file, so some client request comes to read, client request, many request may come here, right? So now we say name node just does RPC, that is remote answer to this RPCs, that is remote procedural calls. So for quick response, name node keeps all this metadata in RAM, right? So that's where we say no demand paging of the metadata, file system metadata. No demand paging. What is demand paging? Demand paging means operating system copies a disk page into physical memory only if attempt is made to access it. I hope all of you understood this point, right? Demand paging. So that means when you run a program, data will be loaded to the memory on demand. But here name node, it is not demand paging, it always keeps the data into memory. That's where we say no demand paging. And what are these types of metadata? List of files, list of blocks for each file, list of data nodes, which replication, so access time, replication factor, entire thing, metadata will be stored in the RAM. Right? So I told you edit log files, right? So records, file creations, file deletions, everything will be logged into the disk also in the name node, right? Probably I may just take another 10 minutes more, friends, because I think first day I just went a little slow. So probably I just need 10 minutes from all of you, right? Please, can I get yes from all of you, friends? I may just need another 10 minutes maximum, right? Thank you very much. Yes, friends. Thank you. Does the processing node work on remote data as well? Transfer large data over network would be difficult. Processing node work on remote data as well. See, first, Anant, you need to understand if you have multiple racks, that means can we have racks itself in remote places and create a single cluster out of them? Actually true, yes, you can do that. So, but data will never, maybe when you copy it, yes, first time data will be stored onto the racks, that is true. But when you processing, right, you say does processing node, right? So now when you process goes to the data. It doesn't mean data will be traveled to the processing layer, right? We will understand this in detail when we go to processing, Anant. How can you integrate ETL tools to HDFS? Basically, we use Pig itself as an ETL tool, Yogi. Right, Pig itself we can use an ETL tool, and then typical ETL tools. Right, nowadays, that's where I said all softwares. Say example, Pentavo data integration ETL tool. Right, so Pentavo ETL tool, again you can integrate directly to Hadoop. They have all their integrations developed now. So probably if you just try and see Pentaho as Hadoop support now. So that's where I said all these softwares, right? So I personally worked on Pentaho and other, and then I worked on again Spring to do on my own. But anyway, example Pentaho again, like Pentaho, all these ETL tools also slowly, if they don't have also, they will definitely within near future they will come out with integration to Hadoop, SDFS, Yogi. Can additional RAM be added to master or it downtime? It will be downtime. Anything Avik. So RAM adding to master may not be possible, right? So again, server will be down. Yes, that's where I said as for maintenance, you want to load some softwares or anything. Say now RAM, increase some RAM, so your cluster will be down. But yes, with high availability, you can take care of this downtime. Like you don't have to worry about this. Now, in fact, in Gen 1, right? In Gen 1, we didn't had this active standby name nodes. This feature of active standby name nodes we didn't had. So there was always a risk. If name node fails, you lose the cluster. So that's where we said name node as a single point of failure in Gen 1. Right? So Gen 1 cluster, if I need to write, it will be something like this. If I need to write Gen 1 cluster, right? Let me copy this slide again. Let me name this Gen 1 cluster. So all these things remain same, but as I said, you don't have this active standby name nodes. So now this is there, and then we can configure this secondary name node. We had secondary name node here. But normally, if you hear this secondary name node, you may feel, okay, this goes down, this may take over, right? That was not true. That was the limitation of Gen 1. Secondary name node just used to take hourly backup from this name node. Right, so now let me explain this point. So this was typical Gen 1. So we say single point of failure for this. That means, so now we used to SPOF, let me write single point of failure. Right, so name node, that means if you lose name node, your cluster will be down. So you might be wondering then what is the use of this secondary name node, right? So that was the limitation in Gen 1. Secondary name node is not a hot standby for the name node. It connects to name node every 1 hour and takes the backup of this name node data into this. So it every 1 hour it tells, give me metadata every 1 hour I will secure, and it used to take and then it used to store it onto secondary name node. It used to just do housekeeping or backup of name node metadata. So once this name node crashes, so we need to manually come here and then take one more server, install all the software, take this data from here and then upload to it and then start the server. So that's where we say single point of failure. So saved metadata can be built from a failed name node. That's all. But again, you might be wondering, say for example, 10 o'clock data backup it has taken from name node. Say assume you have copied some data to Hadoop. Now around 10:45, this name node crashed. Secondary name node has just 10 o'clock data, right? So now in between, if you have moved some of the files, you will lose them also. So that was another limitation. So single point of failure, why we say, because manual intervention is required. We need to up new server and then take this data backup and put it onto it. So that is where we say single point of failure. Right? That's where we say single point of failure. We can take these questions later. You want just understand features? Yes, Anant. Now, after this name node, I think secondary name node, all of you understood, right? So now each file, what happens? It gets into split into blocks. 128 MB in Gen 2, 64 MB in Gen 1, right? So 100 MB, 2 blocks, 200 MB, 4 blocks. Here 200 MB, 2 blocks, 300 MB, 3 blocks. So now, why I have written this small size block here? Because I don't want you to assume, so it is 128 MB, rest of them are free here. No. The last data occupies the exact size of the remaining data. Right? So last block, so final block, you can say last block will occupy exact size of the final data. Is it fine, friends? I think let me stop here. So probably let us come back to this 4 slides, that is 37, 38, 39, 40, right? So these 4 slides let us take up tomorrow, right? Let me explain this architecture tomorrow, and probably these questions also will take up tomorrow, right? Any questions? So please read, please go on and read, visit our blogs, introduction to Apache clusters, right? So now Apache SDFS architecture, probably you can read and come, so that if you have any doubts, you can ask tomorrow, right? So let me take you this trip of our virtual machine tomorrow itself. So please download this and try to install our VM into your machine today, right? Today, if it is not possible, maximum at least you need to try this tomorrow, right? So, but yes, you try to see how to download your VM, right? You take help of support team, right? We will get an email for the link. No, it is there. Everything is there in LMS, Gagan. So you just need to read that PDF and follow that. That's all you need to do, Gagan. So LMS login credential, I hope all of you have, right? So you just log in, probably, yes. So now you see here. So let me connect and show you quickly. Edureka.co. I think I have already logged in. My courses should come. Yes, it is there here. So my courses, it will come here. You go and probably you'll get this. So now just go to this. This is what I was referring as LMS, right? So learning management system, you have link, like as I said, Java essentials. If you are new to Java, you please follow all these programs, how to use Eclipse, how to write programs, all these videos we have, so you can download and practice probably. And then we also have old batches pre-recorded sessions. You want to early prepare and come to the session, you can do that. And all basic things like getting started with big data, how it works, we have here. So apart from this is where our module starts, module 1 today, what we have seen. So here VM installation, right? So you please follow this. That's enough, right? Just download. You don't need to wait for any instructions from support team, right? So, or if you are facing any challenge, please call them or write to them, right? So now each module one, what I have shown now, demo and HDFS commands, Linux commands. So now we'll see one by one tomorrow, and then all these things you can have here, right? We'll see tomorrow HDFS architecture and in detail, right? Is FS image and edit log stored in RAM or disk? Those are files. When I say files, they will be stored on disk, Vijay. FS image and edit logs are files, right? Yes. Namespace is metadata which will be stored on RAM, Vijay. We can take this question later. Just we want to understand failure scenarios for individual nodes. If during processing a node fails down, how does a job gets completed? Fantastic, fantastic, Anand. We will see this early tomorrow, right? So now first we need to understand basic read-write analogy. That is this. We'll just touch base on basic architecture, then file read and write analogy we'll try to understand. In this process, what happens when you read, when you are reading the files, what happens if some of the nodes fails? In this case, when you are writing, what happens? Though next week we'll come back and see when you are processing itself, if the node fails, what happens, right? One by one we'll understand. Yes. Probably you can just try do this small assignment. So set up Hadoop virtual machine, execute Linux commands, try to see HDFS commands on that. We'll come back and see in detail tomorrow, right? So agenda for tomorrow, we will see architecture and configuration files and cluster modes, how to configure all these details, right? So friends, basically we have come to the end of this session. As I said, 4 slides I will come back and explain tomorrow. So before you wind up, right, please give your valuable feedback to us. It is really important for us to understand probably and then improve our training, right? So when I close, you will get a webinar, survey forum. When I close here, you will get a webinar survey forum, right? Please share explanation PDFs document also. Yes, I will do that, Vijay. I will do that. So tomorrow I will give this explanation PDF also. So thank you very much for all of your valuable time, and then thanks again for choosing Edureka as your partner. So now I hope all of you understood slowly. I think it's all getting through, right? If some of the queries still you have not understood, please do write to hadoop@edureka.in, right? So I will also follow through. Maybe I will also check if any difficult queries and then help them, right? Thank you very much. Take care. We will come back and see tomorrow again, morning, again, 10 o'clock, friends. Thanks, Bijay. Thanks, Yogi. Fantastic. Yes, Mayank. Thank you very much. Yes, Shivanand, Sandosh, Sharmila. So yes, Mithun Raja. Thank you very much. Really, your class is very active. Yes, Mithun Raja, basically lot of concepts are there. So now lot of things we learn. So time is very less. So I think it will be really helpful, maybe the way you learn right at the right time, right? So probably that is needed. Thank you very much. So yes, Ashok, Prasad, Kevin, thank you very much. Bimal, Himanshu, Radesh, Iqbal, Yang. Thank you very much. Well understood concept. Very nice, Yang. Thank you very much. So please fill in the survey form. We will come back and see tomorrow. Right. Thank you. Bye bye. Take care, friends.